I guess we are all set here. Rose ma'am, the watching stage is all yours.
Thanks for that. Hi, everyone. Thanks for joining the session. I'll quickly jump in. Um, Before I give a background about what I'm doing, today's session is touching on Python fundamentals. So if you're a total new beginner, you'll appreciate this session. For everyone else who's got a programming background, you might use this as a refresher course. This is going to be a coding session, but in the interest of time, I'm going to do a code walkthrough, right? So just the gist of what we are going to expect in the session. A little bit about me. I'm here in Melbourne and I work as a director at Summit. I've been working in product management. I started off as a software engineer. I've been doing PM work, engineering management. My expertise lies in SaaS applications, API, and most recently AI products. I have a passion for teaching, and so I've been doing research and I've also been lecturing. And you'll see me talking in different conferences as well. It's a side hustle. I'm an artist. I'm a writer. I've been writing on Medium, and most recently I started off on Substack, and also a fitness instructor. The agenda for today is first I'll quickly touch on why Python. So there's not going to be any slides here, and we'll quickly look at the code as I mentioned. We won't be able to do live coding as such, but I've tried to keep a few exercises. So hold on till the end of the session. The first half of the session, you might find it a little heavy because we're going through the basics. Whereas the latter half of the session, for those who've already got a hand in programming, you'll appreciate the latter half of the session, and also at the end of the session, you'll also have some interesting projects. So I'll touch on, the very basics, variables, data types, and then midway we'll go on to data structures, functions, classes. So I'll keep it fast for the first half hour, and then after which we'll slow down a little bit. There's quite a lot to absorb in the latter half of the session. And we'll keep the Q&A for the end so as to not interrupt the session. We'll keep going, and please save your questions, or you can always post it in the chat and I'll take it at the end. Without delay, why Python? Most often we get associated, if we talk about Python, we always think about machine learning, AI, deep learning, but there are various other ways in which you can use Python. And just to give you a little bit of a story, when I was an engineer, I used to look at various web search logs using Perl. So a lot of scripting, and Perl is not easy to grasp, whereas today, Python goes as a scripting language, useful for automating tasks, and it can be plugged into any language. So usually what happens is when you're in research or even in industry, when you're doing a kind of a POC or a prototype, you're ending up doing something in R and Python, or not pre-Python days, you do something in R or Perl, and then when you come into web applications, you're totally coding in a different language. So you've got this two language problem, which is the case that I had. Applications were all web applications, and we used to do scripting in Perl. Now that's gone away today, and everything is being automated using Python. So if you hear scripting language, automation, you're automating all the boring tasks, mundane tasks, you use automation. Now, when I said I came from product, you might be wondering what's the product person actually doing with Python, because usually people would say you wouldn't need Python. No. I look at a lot of Excel sheets. There's a lot of data that I have to look at. So I either will be looking through rows and rows of data using pivot tables, VLOOKUPs. And so that's not easy at all. Whereas with Python, it makes it very easy to visualize the data with various different libraries that we have, right? It's easier than even sometimes looking it up in the DB2. Right? So data visualization becomes very easy than using all various different Excel functions. And as we all know, it's also applicable in the field of data science, right? And it is a precursor, as we may have heard earlier, it's a precursor to NumPy and Pandas. So now why Python? We saw that it's being used in different fields, but what's the reason for any technical or non-technical person to jump onto Python? It's very easy to grasp, so you see that. It's open source, so it's free. You've got a lot of libraries and third-party support that actually plugs in. So it's very easy for you to know minimal and use all the libraries out there. But caution, you've got to know which libraries to use, whether it's safe to use, and various other factors that need to be considered. And finally, we all know that it's great with ML and AI. Now, what I want you to do is I'm hoping that you've got an editor or an IDE. So if you do not know what these are, and edit, you can look up that link, which is right at the top. You'll have an editor, which is just a coding editor, which you can just go and type. And it's got like a little bit of markup, which you would appreciate. Whereas an IDE is going to be fully integrated with a lot of features, like you see in the screen on the slide, Visual Studio Code, PyCharm, Eclipse, and then you've got like interactive Python editors, which are Jupyter and Colab. There's a link in this slide, which I would appreciate if you can go and look it up. It gives you all the detailed installation guides as well. And these are just my top 5. There are a whole load of other tools that you can use as well, right? But PyCharm is like the industry standard. Now, I know this is a get in touch slide, but the reason I'm showing this up here before I close off the slide deck, you've got my Git link and you've got the Cocoa Bytes as well. For right now, I would want you to look up the Git link to get the skeletal code. You can always go and pull that up while we jump onto the code walkthrough. And at the end of the session, I'll also upload the full code as well, right? We will now just move on. So we saw the first part where we said that Python is being used in various places. We've also looked at, the installation. So one point to also note is Python can run in any platform. So if you're today using Windows or a Mac like me, or you're using Linux or any other distribution, you will face no trouble. You've got sometimes Python pre-installed as well, like Mac comes with Python by itself. You might have a dated version, but ensure that you have Python 3 and above. 3.11 is the current version. Okay, I'm running an old version. And main thing to learn in Python is, if you come from other languages, you know that there is like an end of a line should be a semicolon, whereas here there is nothing. And you'll know that when you see the code, you'll see that there is a lot of indentation, and that's the way Python is styled. Okay, so that's the syntax. You've got to have an indent. They don't place the number of spaces, but usually coding guidelines would say about a tab should have around 4 spaces. Okay. Now let's jump in. I'm using 3.8.5. That's my old version, but you might see different versions, and that's totally fine. I'm using Jupyter today, which is an interactive Python notebook. And this is very easy for me to use because it's an interpreted language. And so, sorry, I might just close the poll somehow. It's an interpreted language, so which means every command can get executed, unlike other languages like C and Java. It's compiled, and so you've got this middle language, which is then converted into executable code. Now, we don't have that compilation process at all, right? So, which is why it's very easy. And this is very lightweight for me. I do not have to install anything. And so that's what I'll be using in today's session. Now let's jump into Python. Touching on variables, for the first part, we'll see what are variables, expressions, and statements. Now, we know that when we want to hold data, we'll put some data in containers. And so let's say I have a number or an age. I want to put that in a container. We call that as the container is known as a variable, so which is what we refer to as variables. And we do not need to declare what type of a variable is, unlike other languages. So I've highlighted that. We also have different types of variables, and they take up some memory in your computer. Okay. Now, when I said you do not have to declare them, yes, but they do have a type. So if you're storing an age, it could be a number. If you're storing my name, it could be some sort of text. So internally, even if we do not declare it, we know that that is a certain type. So that's what we call as data types. Okay. Now you've got like scalar data types, which is very basic data types like numbers, text, Boolean. And you've got few more advanced data types, which would fall into like sequence types. We'll look at it. But for now, just keep in mind that we look at the basic ones to begin with. And in the latter part of this notebook, we'll look at the more advanced types. Also note, we have something called as null values. However, in Python, it's a little bit different. You have a data type called none type, and it holds a value called none. Okay, I'm just touching on theories, which is why I'm rushing, but as we walk through the code, we'll understand this a bit more in detail. So now when you look at this, I've said Bluey is assigned, so that's the value, and you give it the name, and when I run it, I'm actually getting the name itself. So if I run it, I just get the name. Okay. So name here is the variable, and there is no data type, which is very clear here. We assign a value 5. So initially, if I do a check here, and if I say type of name, you might ask me what type is. Type is a function which will tell me what is the data type. So it tells me it's a string. Okay, str stands for string. Whereas now here, when I do a 5, I'm changing it. I'm changing it from Bluey to number 5. And when I run it here, and if I were to check what this is, it's an int. So this is called, this is the specialty of Python, right? So you do not have a variable. You don't have to store it, say what type it is. It can actually start figuring out what type it is. It's more dynamic. And the same here. I've reused the same variable to store another number, and that number is float. Okay, so if you're new to Jupyter, each of them are cells, and you use the run to actually run the cells. Okay, and we saw that we wanted to check what type it is, and it is float. So variable assigning a value to a variable, and we looked at that the same variable can be used for different types. Now what's next? Multi-assignment. Now we saw that one variable can hold one value, but it's also quite possible that you can have multiple values in two different variables, but we do it at the same time. And how do we do that? We do that this way. So a comma b equals to 2 4 means that you are storing a as 2 and you're saying 4 goes into b, which is why when I print a comma b, so if this is confusing, if I say a, it prints 2. Okay, so with Jupyter Notebook, I don't have to use a print statement. If I just type the variable, it spits out the value. So if I type b, it prints out 4. And if I type a comma b, it understands and it spits out both. Okay, and it also has complex data types. We all probably would have learned it back in math, where we have real numbers and imaginary numbers. That's exactly what we have is complex. Okay, just keep in mind that we have these data types, but the data types that you'll really use if you're going into mathematical notation is different, but what you'll really use would be integer, float, string, and the advanced data types. Now, when we move on to expressions, let me just talk a little bit about expression. Now, you would have all done this in school. Expression is nothing like an equation. We have like a variable, so an operator. The variable is nothing but operands, right? So a plus b equals c. So that's nothing but an expression. Now in Python, it's the same, except that you might have like shortcut expressions, which we'll also look at how we can do that. When I say shortcut, you might have conditions like if and else. So you might want to have, rather than having 4 lines of code, you might want to say everything in 1 line. So that's a shortcut. Okay. We have different types of operators here. We have arithmetic operators, which is our plus, minus, into, multiple, division. But ones that you should look out for are, we have the exponent, which is like the power of operator. We have integer division or flow division, which is nothing like if I say 4 divide 4 flow division of 2, it gives me the quotient. So just like modulus would give me the remainder, integer division or flow division would give me the quotient. Okay, that's the only different one that you need to watch out. Comparison operators are all anything to do with comparing 2 values. So whether you're checking for equality or whether you're checking for not being equal or less than, greater than, things like that. And the next common one that you would use is AND. So whenever you're doing any operations involving conditions, you might use these logical operators. You're comparing Boolean, which we looked at what Boolean is, but you'll use logical operators, right? And assignment operators, which we saw. But the reason I call it out here is there's also shortcuts to the way we use assignment operators. We'll take a look. All these I'll explain with code, but just keep in mind. Bitwise operators are operating at bit level. So if you want to do like a shift on a particular number, you want to add zeros on the right and the left, we use bitwise operators, right? That's a totally different level of operation. Membership and identity operators are something unique to Python when we say in, not in, and is not. Keep in mind, membership operator is something that you'll use for checking if a certain value exists in a list of values. So let's say I have a box of 10 chocolates. I might want to check to see if one particular chocolate is in that list. So that's when you use in. An identity operator is or not, you're like checking to see with, let's say if it is usually used for none. When I said you have a null value, you want to check to see whether age is null, okay? Something like that. Should I take a question? If you can share links in the chat, sure, I would do so. So that's the Git link. You can probably take it from there. The other IDE article that I was talking to you about, I can give that to you in a moment. So the next link that I'm posting is if you're stuck with IDs, you can probably look at that list. What other links do you need? That should suffice for now. I'm hoping Analytics Vidya will give you the link. Okay, now let's move on. I'll try and make this slightly bigger. I hope that is visible. Now, let's move on to precedence of operators. All operators do have an order. So let's say you have an expression with a whole load of operators. You will have to know which order in which you should actually perform the operation, okay? And you also have statements, which are assignment statements, is when you're assigning some sort of a value to a variable, okay, theory. So now let's quickly look at what that means. So when I said arithmetic operators, I am just going to show you a quick one, okay? So that's just doing a sum. And let's say if I did floor division, it's kind of saying 2, okay? If I do something as 5 divided by 2, 2 times 2, 4, it just picks only the integer. And if I change that to modulus, you get a remainder of 1, okay? So you can either do it this way, or as I mentioned, you can store variables also and do it. So I can always say 4, and then I can say C equal to A plus B. Then we'll see what happens here. Okay. Nothing happens because I'm not showing anything, and then let's see what happens here. Okay, so that's when you have a simple expression. Now, exponent, 2 times 2 times 2, it gives you 8. Flow division we saw, modulus we saw. We saw multi-assignment, so I'm going through that as well. And then we also looked at expressions. Now let's come to assignment operators. I mentioned that we have shortcuts, right? So if you notice here, I have said a plus equal to 1, which means it's equivalent to saying a equals a plus 1. Okay, it's the same, right? I've just combined the two. So you might want to also note that I'm using the hash symbol here. That's just to say, do not execute the code. It's only a comment. Okay, that's what it means. So let's do one thing. We will take what's the value of a here. A is 5. Let's reset it. A is 5. A is 5 plus 1 is 6. Okay, so that's correct. Now, operator precedence is nothing but if we were to do some maths here, we'll say 2 times 3 is 6 minus 1, 5. So obviously, the multiplication gets a higher precedence over 1. And so I wanted to go back later and look at what the order is. The order is usually parentheses, exponents, bitwise, and then arithmetic operators. However, we will usually avoid the bitwise operators because usually we do not do much in the industry, but something to notice, you'll use more of the comparison, identity, and membership operators as well. Now, moving on to concatenation. What do I mean by concatenation? Now, I'm saying that name has taken this string value, but I'm also saying name plus a. What happens here? I'm getting an error. This means what does this actually tell me? It says it cannot concatenate string with int. That's trying to tell me that I'm trying to perform an operation on string and on a number. A is a number, which doesn't make sense. So how do we avoid that? We'll take a look. You use something called as casting, which means you can join the two. Okay, we'll look at functions and this will be covered there, but something to keep in mind. Also, an addition can be performed on a variable on a string. What would happen? It just duplicates it. So as you can see here, variable has frozen and I'm used in addition here, it just duplicates it. Okay, and it's the same with when you use the multiplication as well. Okay, so there are ways in which you can use the operators which you would have usually used on numeric integers. You'll probably use it on other types as well. The next is comparison operators. Comparison operators are basically you're checking for equality and non-equality. Something that you need to note is they return a value. So when you say 23 equals to 23, I'm not assigning any variable to it, but what it returns to me when I run it is it says that it is true. Now, true is, you can say that it is bool here. In other languages, we say boolean sometimes. So it takes two types. One is true and false value, which is what you would try to get in most conditions that you might use. With logical operators, they can also be used. So here you would say true or false and false. Okay. So what happens here is one true, and so it evaluates to a true because false and false is false, and one true or false is always true. So it's a combination. I've given you examples. The notebook would be published. One that has on Git will have most of the code, but some of it would be left for you to do it as an exercise. Okay. Now, moving on to the next part, which is built-in functions. So Python allows us to use certain functions, which we do not have to, state explicitly what file we are using or anything like that, but they just give us some ready takeaway functions, which we can use for various purposes. So I've listed few, but there are well over 80. So I've just taken out a few which we would want to look at. Now, what happens here? I'm using a function called input, and I've given it a display string. So when I run it, it tells me enter your name. Where is this coming from? This is coming from input and the string that I enter. So it's giving me an option to enter my name. So I can say Rose, and it tells me what the length of the name is. Okay, there is something wrong here. Why? I am trying to print name, and I'm assigning it to artist. So let's see what artist is here. Okay. So the length is 4. Okay, so it picked up another variable which I used previously. So this is why it gave 9. But now in this case, you can see artist is roles and the number is 4. Where did the number come from? I used another function called length. So you use length to get the length of a value if it is a string, and you use input to actually get input from your command line. Okay, you want to get input and enter some sort of a value. Now, you remember I said you cannot use strings and numbers together, and I said we'll cover that later. You have functions to actually convert numbers to strings or any type of value to another type of value. And so you'd see this where I would say string of str of age. Now, age is a number as we can see here, but what happens is when I use str of age, it converts it to a string. Artist we know is also a string, so string plus string, it should work. So the format here that I've used is the variable. Then I've said, used double quotes here to say I want this to be printed, it's a literal. And then I've used the function string on passing age as a value, and then I have printed it. Now, for those of you who are really new to coding, I know this might be an overload, but if you're with me from coming from other languages, then you'll find it easy, but I will slow down a little bit when we move into functions where all this would get covered. So picked up 30, it picked up rows, and it says 30 years old. Okay, so it picked up the name, it picked up is because I'm saying print that with a space. Then I've converted age to a number, to a string from a number, and then I have also suffix the text. Now, that's exactly what casting is trying to do. You choose any value and convert it to another data set. Okay, and those are all examples of the same. You want to use int, you have a float and you convert it, you should be able to get an integer. So 3.4, if you convert to an integer, it's going to be integer, right? Because it cuts off, it truncates the decimal. Whereas for float, the other way happens. Even if you pass an integer, you'll get the decimal and a 0. Okay. Now let's move to flow control statements. Now, in general, we'll just talk about what flow control statements are. Flow control statements are when you have conditions, like if you want to check if a number is less than 100, right? That's a condition you're trying to check. Now, you might have one condition. If it's only one condition, you use if. If you have multiple conditions, you would use, say, if and else, and else, we'll see. If you just have one that you want to check against another, you have if and else. So there's few combinations, we'll cover that. And for and while are for like repetitive execution. The difference between while and a for, while is once again based off a condition, whereas for, it's like a fixed number of times that you would execute. Often you misuse while and for, but for, the clue is if you know the number of times, use a for. If you know a condition, use a while. That's for repetitive. If is not repetitive. Continue and break. Break is like when you want to stop execution, and continue is actually going back to the beginning of the loop. Now we'll quickly go through. We are at the half-hour mark, so I'm going to run through this quickly. If you have age as, say, 17, and I'm checking here to see if you're greater than 18, then I'm printing that I'm an adult. And if I'm not, I'm going to say minor. That's basic, right? So that's the intent that I was talking about. So what this means is you've got an if construct and you're printing that with an indentation here to say that, hey, if I'm more than 18, print me this. If not, I'm going to print. So the scope of this print statement is for this else, and the scope of this print statement is for this if. Elif is a little different. So let's say you have more than one condition, right? You have less than 18 as one condition and you have more than 70 as one condition. So what do you do with that? So you have, it doesn't fall into else because you have two different brackets, less than 18, greater than 17, and somewhere in between and beyond that. That's when you use an ellipse. So if you have two conditions which you want to place, you use an ellipse. Okay. So in this case, I've said 19. Let's just run this. So is 19 less than 18? No. Is 19 great? No. It doesn't satisfy these two, which is why it comes to this. Now with this one, we will be looking to go into a while loop less than 5 times, which is why it goes through 0 to 4. For 4, range, this is another inbuilt function. What range does is, range would take numbers 0, 1, 2, 3, 4. So 1 less than 5. So 5 numbers are 0 to 4, which is why it spits out 0, 1, 2, 3, 4. Now continue though is, I've said that, well, what did I say? It should go to the beginning, right? So here what I'm doing is, given number 0 to 10, you're trying to exclude 2. So what does that mean? So in a range up to 10, so 0 to 9, if I is 2, so whenever I traverse, if I encounter a 2, I go to the beginning of the loop. Continue. So if you look at the output, you'll understand that. 0, 1, 2 has been skipped. 3, 4, 5, 6, 7, 8, 9 is printed, which means you're going to the top of the loop, right? So you skip that, which is what continue is saying. Please jump off, continue with the remainder of the loop. Now, break is different. Now, what break does is, whenever it encounters a 2, I'm saying break, stop the loop. It doesn't execute the remaining 8 times, which is why you see 0 and 1. Okay. Now, good to know. Most people won't know this. With a for loop, you can also have an else. We always talk about if and else, but it's also possible that you have an else. You might ask me why do we have to have an else for a for? But once you have that fixed number of iterations and you get that done, you might want to print something else. So sometimes you do have an else. It anyway gets executed. Okay. We'll talk about modules, but I'm going to quickly run through modules in other sections as well. But modules are external files where you are trying to import them and use them so that you can call those functions. So you might want to write your own function, or you might want to use functions which have been written elsewhere in a totally different file, not this file. You are sitting somewhere else in another library. That's when you use modules. And some modules could be custom built, like it comes with Python. There are some modules which you will have to import and install. Okay, so that's also possible. Okay, let's move to sequence data types. We'll quickly cover this. We spent 5 minutes before I shift to the next module of the session. Now, the sequence data types are all of different forms. There's like, you've got like list, tuple, and set. The difference here could be seen from this image. When I say mutable, it means to say it can be changed. So anything in a list can be changed. It's an order, which means there's a sequence to it. It can index, which means you can access it by an index. And it allows duplicates. That's how you read it. Now, tuple and sets are different. They're not mutable, and whereas a set is not ordered, doesn't have an index, there's no duplicates. Okay, so this is hard to get at. So you might want to keep revisiting and playing around with the various functions that come with these sequence data types, which would help you to figure it out over time. Most often you'll use lists and sets, because sets do not have duplicates. That's something you'll want. You'll also come across dictionaries, which are very frequently used. We'll cover that as well. Now, quickly to touch on lists, you might want to, we'll look at this. I'm creating a variable called movie list, and list is another function, just like string, int. It's another function in which I can pass certain values. So I'm passing certain values and I'm creating a movie list. Okay, so here movie list would say that it has these 3 movies. So that's a list. So that's how you create. If you do not have anything, it will be empty. Now, another way to initialize it is directly passing it. Okay, it's square brackets. Please note that it is square brackets and it is separated by a comma with apostrophes as well. Okay, now when I said you can access it by index and there's an order, cat would be 0, this would be 1, and this would be 2. That's an order. You can also go in reverse order. -1 is kangaroo, -2 is emu, and -3 is cat. It can go reverse as well. That's an index. So which is what you will see in the code. Now, unpacking a list, similar to multi-assignment, but here what happens is you want to say animals can be assigned to 3 because I've got 3 here. So each animal 1 would be cat, 2 would be MO, 3 would be kangaroo. So that's also possible, and that's called as unpacking here. Now, various ways of creating. You can also create a list within a list. So here, what I'm trying to do is animals was a list, and now I'm passing on a second list to create planet as a list. So planet can have animals, plants, and humans. So this is a square bracket should tell you that it's another list. Okay. So planet of 1 would actually give me plants and human. Why? We said the index starts from 0. So animals is 0. And this whole thing goes as a list. Within the square brackets goes as a list. So it's 0 and 1. But however, when I say planet 1 of 1, in turn, planet of 1 has its own list, which would be indexed as 0 and 1. So when I say 1 of 1, it is human. If I say 1 of 0 and run it, it would be, okay, let's run it. Let's run everything. I'm getting those errors because I have not run this, right? So let me run it and then let's see. So 1 of 0 is plants. Okay. Now slicing is going to be 0 to 2. And what does this mean? We're going from 0 to 1, because the last one will tells you that do it as go up to -1, right? So it's 0 and 1. If it was 4, you'd say 0, 1, 2, 3. So it prints out cat and emu. Now, if I don't see any numbers at all, it means print the whole list. If I see 2 colons and a number, the last number would denote how many jumps. Okay, so if I had cat, emu, and kangaroo, it says skip 1. So it meaning to say if I had 3, it brings me 0, and then it skips this and takes me the other one. Okay, so different ways in which you can slice a list. Now, when I said mutable, when you can change or add or remove, that's what you mean as mutable. So we are able to change a list. You are able to expand a list. Expand a list is when you want to attach a new list to a particular index location, and it can be larger. So that you'll see that in one index, you're trying to actually add 3. So it's an expanding list. Okay. When you go through the file, you'll notice that there are a lot of delete and remove. There's repetitive code for you to execute and try yourself. So that's something that you can do. Now, traversing through a list can also be done using for loops. So when I spoke about in, it means we were trying to say if 1 exists in a whole list. So a list is like an iterable. You'll also hear that word. So what we're trying to do here is get me the whole length of animals and then give me that range. So if the length of animals was 3, the range would be 3, the range of 3, which means 0, 1, 2. Okay. And it would print. Now, in the case that you're seeing here, that's because I've done a remove, which is why it prints only 2. Okay. So the list is at cat and kangaroo. And the next time when I iterate through the list, it prints what that animal is in that particular index, and it iterates again and it prints it out. Okay. I've given different ways in which you can go through and append and insert into the list. So you'll look at all these. These functions were added as for you to go and work it out, but they're also there in the Python docs. Lists out all the different list methods. This is a very small set which I have picked out for you to go and have a play. Okay. Now, let's look at tuples. Now, what's the difference here? We are looking at, the one thing is that you'll note that they have a parenthesis versus a square bracket, okay? And they are ordered, which is the same. They can have duplicates. They are a sequence, but what's different is immutable. When I say immutable, I can't do this. So if greetings was hi, hello, and hola, greetings of 0, I'm changing that to hi, which is not possible. I can't change it, okay? So that's why I'm getting that error to say it doesn't support item assignment, so which is an issue. That's the difference between sets, between tuples and lists. Now, what's with sets? Sets, once again, differentiated between the parentheses that you use here. And you can, similar to list, you can use a constructor to call it and initiate it using the keyword set, and you can add. Now, something to note is I already have a set here with A1, and you can note that here I'm trying to add A1. What happens? It doesn't add it because sets do not allow duplicates. Okay, so that's the main thing that you need to remember. They do not allow duplicates, and they also are. There's another type of set which is frozen set as well. You'll notice there's a subtle difference. Okay, so we say sets are mutable that you can remove and add, but the difference with the frozen set is that it's a completely immutable set. Okay, but most often you use it. Same, I have listed various other functions, set methods that you can use, which you can always have a play with. Okay, so you can add, you can try removing it, you can try discarding it, you can try to see how you can update it similar to the list method. Now, something to see which is a little bit different is dictionaries here. Dictionaries here are, you can say it's indexed with via a key. They are actually key value pairs. So it can be like, say, you have a student and you have a roll number, right? So it could be roll number and student. So that's like you associate it unique. It may not be unique, but in this case, when you would learn that key value pairs end up being unique as well. And they can be, the later version in Python, if they are ordered to. So because of the key value pair, you could say that there are no duplicates. So to give you an example, you have name here. How would you read this? A curly brace, which is used, meaning to say it's a dictionary. And then when you have name : Bima, age : 16, comma, date of birth 2001, it means to say name is a key, Bima is the value, age is a key, 16 is the value, DOB is a key, this is the value. You notice that I have used a backslash here. That's telling Python to say, just for readability, that I'm splitting the code and do not execute it. It doesn't mean anything. Okay. Now, how do we operate with risk? It totally depends on all the inbuilt functions that we have. You have functions which are called keys. There's a function called values. There's a function called items. So you use your loops to iterate through keys. You'll be able to, well, let's run this one. Okay. So if you see this, you can see that you're printing a dictionary. You're printing person of age. So here there's an index. I said they are indexed, meaning to say you can access it via the key. And here when I said keys, it's actually printing name, age, and job. Okay, that's the 3 keys. Same way you can do it with values, and you can do it with items as well. You say what items is. Here you're trying to say key is name and value is Bima. Okay, so now if I want to check for a particular value, this is how I would do it. Name in person. Meaning if I want to check whether name exists in person. So when I run it, it would say true. Why? Because name is there. So that's a membership operator that you're trying to check for. Similarly, you have various other dictionary methods. The way we would usually work is you'll have to look up your Python docs. Some of the IDs would help you with that. You can have IntelliSense, which is like your code will have code completion, which will help you to with the API description, which is very easy. You might ask me, how do I remember all these are methods? The main reason I'm doing this, it comes with practice. It also comes with having docs installed. It also comes with various other tools. Okay. Now I've kept a coding exercise. Please take a look at the coding exercise and try and give it a go. I will upload the solution. The one that you have on Git is I do not have the answers. So give it a go and I will upload it later after the session. Okay. Now let's quickly look at strings and then we'll move. Okay, strings are nothing but a full set of characters, and you can either use single quotes or you can use double quotes. So single quotes you could use this way, or you could also use double quotes like this. Okay, when should we use? If you have other characters which you do not want to use the escape character, then you use a double quote. But if you want to use escape characters, then yeah, it would still work with a single quote. So different ways in which you can do it. The rest of this file will actually talk to you about formatting. One key area which I wanted to look at is something called f-string. F-strings is if you want to substitute a variable in when you're trying to print. So here I have a print, which I'm saying my name is some name and I am such so many years old. How do I do that? I have a F in front of it. I pass the variable in curly braces and I pass the next variable in curly braces. Okay, there are more modern ways of doing it using templates as well. Now that is the end of the string one, which once again, string has a lot of methods, which I've added for you to take a look. But feel free to have a play, okay? Your questions on Excel database, F-value V3, yes, we will keep your questions. Excel database is probably I will cover that later in the next session if I'm running one. This is Python fundamentals. I won't want to get into more detailed topics, but yeah, depending on how the time goes, I can get up on that. Functions. Now we saw that Python had pre-built functions, whereas now you can write your own function. And the key way to actually do this is have a keyword called def, and then you have the name of the function, parenthesis, a colon is important here. And then if you're not doing anything in the function, you just use the keyword pass. If you have something to, you perform some sort of a computation and you return a value, then you use return. That's what you'll see here, okay? So you'd say define, so that's def, add. I'm taking two values here. You might ask me, what is this? N1 and N2 is taking two arguments, N1 and N2, and I'm going to sum it up and I'm returning that value. So the syntax here is important. You need to remember that the first line has a keyword, it has a function name, the arguments, and a colon. Okay. Now, let's look at what we are trying to do here. Okay. This one is a little different. We always think that return can return only one value, but it can return many values too. So what I've done here is I have an artist, I have an age, and I'm also trying to return artist, age, and Melbourne. So comma separated, and how would it actually understand what it needs to print? It just prints it out as achievement, comma Melbourne. You can also use multi-assignment and print it that way. That would also work. Now, how do you call a function? So I call a function saying get person details with the parentheses. And I'm just enclosing that in print because return means it's returning three values and print actually doesn't have any return value, okay? Something to note, the print function doesn't have a return value. It just takes what is within the quotes and prints it onto the screen. So when I get a return value from person details, print knows that it has to print that value onto the screen and it prints it, okay? Now, this is something interesting for you to see. Print, when I said doesn't print anything, it doesn't return anything, it prints nothing. But what's the type? The type is none type. If you remember, I spoke about null value and none, and I said it's of type none type, that's this, okay? So it's the same here, same example. You might also see that print has various different ways in which you can print. So you have separating characters, like if you want to separate it with a comma, and you have a ending character, which you can have a full stop. Now, next part is scope. Why are we so concerned about scope here? What is scope? Now, functions can have their own variables, and it can also access variables from outside of the function. Now, let's see why this is throwing an error. So it has a function called ch equal to 123, and it's printing. What does Python tell us? Wherever the indentation is, that's the scope. So print is actually outside. It doesn't know what ch is because ch is part of this function. So when I print it outside, it doesn't understand what ch is, which is why it says ch is not defined. How do we go about solving it? We declare it outside to say it is a global variable. There are ways in which you can do it. But let's take in this case, we've said that ch equal to a. And now we've said ch is equal to b. Let's see what happens here. It says inside function b. So what happens here is print local character has a character b, and I'm printing it that. So it knows, it understands it because it's in the same scope. So it understands it and it prints it. And I call the function outside print local character that's called, which is why it's printing it. And then I print outside function ch. Now outside the function, what's the value? Which is a. Okay, so it's outside. Now there's also a global keyword. What if you want to use this value inside, right? So that was the problem here. We can overcome that using the keyword called global. We say global ch. Then we say ch equal to 23, and then you're able to print. So the very same problem here, which we couldn't print, is now overcome using the keyword called global. Now, this is going to be a small exercise for you, but I'll probably give away the answer. You can also have nested functions, not used often, but you can have nested functions as well. So here, the way you want to read it is you've got like a phrase here, which is speaking, and you've got like words, which you want to like split, right? So you have a whole sentence that you're talking, and each one you say a particular word. So you want to print every word in the sentence, which is your inner function. So the inner function is say a word and it prints the word, but how do we know what the word is? So we are saying take the phrase, use the string function split using the quotes or the space in the quotes, and then you iterate through all the words, and then ultimately you get say W. What am I doing? Say W, which calls this word and it prints. So if I call the function, I call the outer function, and I say speak, what do I know? The scope of the inner function is only relevant to speak. I can't call. So it calls the outer function speak, what do I know? And then the call comes here. It executes this, then it executes this, and it calls this function again, say W. So it splits the word as what do I know? So each time it splits it, it will split it as it splits it once. So it splits it into 4, what do I know? And then it goes into a loop of those 4 words. It's a list, and then you print it out. Okay. Now, advanced concept, but I'll just touch on this. There are variables which are outside of a function, which are used only for read-only purpose, and that's closure, concept called closure. There are also ways in which you can access that variable, which can't be modified, and modify it as well. You use the keyword called non-local. So if you look at what I'm trying to say is, if you have a number here 19 and you're trying to increment it, you can't because you have only read-only access. Now, if you want to change it or increment it, you have to use the keyword called non-local. Okay, so that's the only way in which you can modify a variable which is declared inside of the outer function. So it can be declared inside here, or it can be declared even as an argument. Okay. Now, while I'm talking about arguments, something to note here is we can have different types of arguments. One is positional arguments, which we spoke about, which we saw. The other is keyword arguments. Keyword arguments are like optional arguments. You might have a particular argument with a set value. Okay. So an example could be like your print, which is your separator and int. Those are keyword arguments. Okay. And so you can have user-defined functions also the same way. So I'm here to give you an example. The keyword argument here is, now we are having A and we have L, and then I'm saying that list is going to be a empty list, and I can append to the list. I can also set a value here. Okay, so that's the difference that we are trying to state in our arguments in a function as well. Okay, so subtle differences in the way you can define and pass arguments. You'll sometimes hear the word parameters, arguments and parameters. They are the same, but they are also different at the same time. When you define your arguments and passing it, they are parameters. So there's like a slight difference, but it's all about what values get passed in the parentheses. Now, there's also a coding exercise to the bottom of the notebook, which you will, I would leave that to you, but there's nothing to talk about in detail, concepts which I have covered further on the top. Now, let's look at classes, and let's also watch the time. Now, classes are something which you use as a blueprint for creating objects. Now, what does this mean? So let's say I am a person and I am identified by my name, by my address, date of birth, age. So person here is a type, right? And all these other different characteristics are what define me. Those become like variables that define the class. So an object is actually, I am one type, like I'm an instance, and another person, say in one of you, could be a separate instance, right? So we are like carbon copies, but in each one has its own type as well. So a class is like a template, but each object has certain unique properties too. May have, okay? So a class is a blueprint for creating objects, and objects are instances of classes. Now I'll take a fairly complex one to give you an example. So you have a class name and a colon, always a colon, just like functions. And then you have def, which is to define. And classes usually have an init function. And here, if I want to explicitly state it, I use a double underscore init double underscore. And I use the word to say that you're calling that class, but it can be any word. Okay, I can say s or anything else. It doesn't have to be the word self, but it signifies that that is the object instance. So, and you pass in the variables that define that class. So here it can be name or age. Okay, they can also be defined in the class. So I can also specify, doesn't have to be passed as arguments, but it can also be defined inside the class too. So like this, that's also possible. Okay, and then I assign it, which means I'm actually declaring and defining my variables here. What you would see here is when I try to print an object of the class, I want it to print differently. We'll take a look at what that means. And here what I'm doing is I'm defining a user-defined function. Okay, so you have get asset and you have the asset name here, and you've got like asset age here. So I'm passing the instance and I'm saying, tell me what the age is and tell me what the name is. How do I instantiate? Pass the class name, okay? Then I pass what exactly is the name and what is the age. So I'm passing a asset here. So let's say the asset is a technical asset, which is a mouse or a keyboard, and I'm saying it's 1 year old. And I create a variable which is A3. So A3 is of type class asset. And now I'm saying print A3. Okay. So when I print A3, should be the same. Okay, let's run from the top. Okay, so when we say A3 equal to asset mouse of 1, we are saying, and print A3, what we are saying here is print takes in this inbuilt function, which I have said, print for me with the name and with the age, which is why it's printing as mouse. And I've said, use the parenthesis, so it's using a parenthesis. So I'm like trying to force an override saying print has to follow this sort of a pattern. I do not want the standard way of printing. Now, A3.getAsset is my user-defined function, which is why I'm calling it differently. So getAsset is a part of asset. It's a function belonging to the asset class. So it needs an instance, which is A3, and I call it as instance.function name. And so it prints the print statement, which is here. So which is typically the format. Now, when I said that there could be classes and objects which have their own identity, it's an example of inheritance. Always inheritance is an ISA relationship, meaning to say that here in this case, a tech asset is an asset. So I try to say that tech asset is of asset type. So inheritance, the class type is asset, which gets passed in the parentheses. So this is the way in which you know that it is inheriting from another class. And you use the super keyword if you want to call the init class, which I've defined here. Okay, so I'm forcefully saying, when you execute this, please call the super class. Okay, and I have defined its own method. So a method doesn't exist in asset, but I've defined it here saying tag that asset. So it's getting the instance, and I'm also printing F strings. If you remember, we spoke about F strings. We have an F and we did spell out what that string is, and then we pass the variable name here, and I'm having another string here. So it's like your string concatenation, but a different way of formatting strings. And so what it does is I've created now a class, text asset and instance. How am I instantiating it? I'm passing Bluetooth mouse, the name, I'm passing age, and I'm passing logic. So self just signifies that it's the instance. You do not have to say anything here when you actually call or instantiate a class. Now, when you call the method, you would say ta.tag asset. It calls this method and it prints it, text asset. It takes what the name is, and then it says has been sent. Okay. Now, the last part of the session would be exception handling and files. Exception is if there's something which shouldn't be executed in a certain way, it throws errors, and we've seen that. We've seen areas of my code which is red, meaning to say it's not being executed well for whatever reason. So we want to handle that gracefully. We may not be able to avoid the error, but we want to handle it gracefully. That's when we use something called as try, except, and finally. Now, what's the difference? Any code that you think might throw an exception is always put in a try block, and except is the part which will handle it, and finally something which if you want will you can always have that as a code which should execute always. So in this case, what I'm trying to do is I'm trying to divide a number, but my divide is 12 by number, which is written in a try block, and I'm using the keyword except. With the error which could come is if I'm dividing by 0. What happens if I divide? It catches that error and it says print this and then say divide unsuccessful. So when I call a function divide of 0, 0 gets passed here. It says 12 by 0, and then 12 by 0 obviously would have a problem. So it's a division error. So we print invalid, and then it also prints divide unsuccessful. Okay. So if you want to run that, you can see. Okay, so that's what happens. It prints invalid, and it anyway prints whatever is here. Now, let's think of a situation where we want to deliberately or on purpose throw an error. We use the keyword called raise. So this is not an error in my code, but I am throwing an error. I want to say that something has gone wrong. So I'm saying here that if it's 10, y is 0, and if y is 0, I'm saying throw this exception saying it's 0. Okay, so you might want to also do that. Okay, most often you'll handle it, but that would be custom errors which you would use. You'll want to raise or throw an exception. Now, these are all exceptions which are inbuilt, which come with Python, but you might also have user-defined exceptions, and that follows inheritance. So which is what we are trying to do here. We're trying to have a class here which is the invalid input, and it catches an exception which is of type exception. So that's inheritance, and I'm actually defining what could go wrong here, what that exception is. So the same way I have a try block and I have an except block. Finally, as I said, is optional, but you want something to always execute. And you put the code in here where you would throw that exception, and then you catch it. Okay, so here I've said the number is 18. If it is less than that, you raise that exception. Otherwise, you print valid, then you catch it, and you say it's invalid. Okay, so which is why now when I said number is 67, what happens is here, number is 67, is it less than 18? No, so it comes here and executes the code, valid. Okay, so it's not throwing an exception, and which is why this is not printed. Last part, files, before we move on to a few projects. Files are, let's say you have files inside your system and you want to open it, or if you're moving on to now other more complicated or more complex logic in your Python code. Today's session is very basic, but if you want to start reading files, performing operations on files, you'd probably start looking at functions like open, read, write. You had various different modes. You might want to only read a file, you might want to write or append, you might want to read and write or write and read. So there are a few more other modes which I have not mentioned here, but there are different ways in which you can read files, which are either text or binary. And so here in this case, I'm having a file abc.txt in the same directory as where I have this code. And I'm saying open it. And let's see if this actually runs. Okay, so it does run. So I have a file here, and it actually reads that file and it displays everything in one line. So you can read files as well. You can also write to a file from here too. And provided you've got one thing when you execute your code, you need to see is whether you have permissions on the directory, permissions on the file. They've got to be in the current directory. In case you're using Collab and not Jupyter, please make sure that you mount your drive. Otherwise, you would not be able to execute it. Okay, and the same way, something to note, you also have to have exception handling when it comes to files. Okay, so why? Because there are chances that there could be something wrong with your opening of the file or writing of the file, or some issues could happen. So which is why you'd have like a try except finally block here, trying to say, open that file, you write something to it. If something goes wrong with the opening, you catch it. If something goes wrong with the writing, you do something. Okay, so if you try that out as well, you'll have the same. So here in this case, you're trying to open it, and I've said you write it. But if you have a problem writing it, just say that something is gone wrong with the writing, and you close it. But if something is wrong with the opening, then it switches here to say something was wrong with opening the file. Okay. Now, we do not know which one would execute, which is why it's a good convention or coding practice for you to always handle different file operations. Okay. But a shortcut to that would be using something called with. Okay. So if you see the way the same code is written, it's very different here, right? You might ask me why are all these lines missing? No, that's because it handles everything very gracefully, and in case there are exceptions as well, things are all handled. Okay, so with, and you open it, and if you open it as a file, and then you can always read it and print that content. Okay, do we still have time to go through a little more?
If you're okay with continuing, we can continue.
Yeah, there's probably another 10 minutes, and then I might have to wind up. Some few advanced concepts here are lambdas, map, reduce, and filters. We'll look at what they are. I'd like to touch on these topics because this is something you would definitely use when you get into Pandas. Okay, so the rest are all basics, which will help you to get a hang of the language, but these are all concepts which would lead you into NumPy and Pandas. Now, what's lambdas? If you've worked with other languages, you've heard of anonymous functions. So think it to be something similar, but the way you would actually use this is lambda, argument, and expression. Okay, so that's the syntax. So in this case, if I say lambda x colon x, the argument here is x and expression is x, and the result is stored in there, right? So 5 is what I'm passing. So when I say best use inside like, okay, no, I should probably say this. Argument, this is something to know. Argument is passed in the result. Okay, so result of 5, most often we don't know how we call it. You use the result and then you pass the actual argument here. So result of 5 will actually say, okay, the argument is 5, and what am I supposed to do? Return 5. The same way here, what am I trying to do? Let's interpret this. I'm saying multiply 2, multiply one variable twice and store it. So I'm taking 2 and I'm multiplying it. So 2 into 2, and that gives return that value. So you're actually trying to say, perform some operation and give me that value. Okay, and it's not that you should have only one argument, you can have 2. So in this case, it's x comma y, which means I'm trying to say multiply 2, which is 3 and 4, you multiply and return the value. Okay, so it's easy for you to use lambdas inside of functions. It keeps your code also clean, not just from a data science aspect or data analysis aspect of it, but even just for Python coding, web application coding. Now map, what is map? Map is actually similar, something, it takes in a function, okay, but it performs that function on every item in an iterable. So iterable is nothing but a list. So let's say the list is this. It takes every item and then performs a function on it. It's always easy to read the code when you look at the actual function itself. So here it's double. Double is, you're trying to double A and you're returning that. What's the syntax for map? Map is taking two arguments, which is function and iterable. So you're passing in double, which is the function name, and you're passing the list. And what would the results be? It is doubling each of the numbers. So it returns the same number of items as in the list. You can also use that. I've given that as an extra exercise. If you've taken it from Git, I would have given this as an exercise for you to do. You combine lambdas as well as you combine map and try to keep your code short by using these two functions. Now, what is filter? Filter is also a function which takes arguments and an iterable, but it will actually help you to filter out certain items based on a condition. Now, here you're actually carrying out a function on each item, whereas filter is actually you're performing a conditional check on a value. So if you want to check take an example. I'm taking an even number and I'm checking to see whether it's an even number, and I'm returning whether it is or not. So filter, function name, and then I pass the list. We will return that into a value called result, and when I print it, it gives me 246. Okay, so it checks to see from the original numbers list 1, 2, 3, 4, 5, 6, which of those numbers are even. Okay, and it returns those values. So that is the meaning of this function. Final one is reduce, and reduce is going to actually reduce the whole iterable into one value. So all these other examples that we saw were performed on every item, whereas this one reduces it to single. It still executes a function, but it executes on all the items in a iterable. Okay, so something like, also something to note, we've not taken a look at this. When I said we can import modules, Python inbuilt modules, this is an example of it. I'm trying to say from functools. So functools is a module, and I'm trying to use the function reduce. So it's from, either you would say from functools import star, or you could, if you know the function, you'd say reduce. Okay. So you import that. Reduce is, it needs this function declaration or the import declaration here, and then you call that, and I'm passing a lambda here. So I'm changing it a little bit. I'm using a lambda function to do the same operation. What I'm saying is, let's do this together actually. We know that reduce has to take two arguments. One is the list, that's numbers, right? And then it also has to take a function. So we are trying to do lambda. Oops. Trying to do lambda, and then I'm trying to do a, b, and I'm trying to say a plus b. Okay, so let's put this in parameter. So always try to start with the function. You can free to write it as a separate function, or to make it, because declaration gets a little complex, it's always easier to clear out everything. Write your lambda first. After that, you know that the second argument is your list, and then you will be able to print your values here. Okay, so let's do numbers. We never ran it for this session. These are all previously run, which is why you're able to see my output. But let's just run it again. Okay, so that's what it does. Now, final parts, I've given some nice to have and some facts, but most often, which you might need to when you go and run your this Python notebooks, is pip. Pip is a package manager. You will have to install it, and it helps you to install other modules as well. So first is you need to download pip. I've given instructions to download. It's a package manager. You will also use other modules which are outside of Python, which will also help you with by having pip as the package manager to download it. Now let's do some bit of fun here. So for those who are pretty new, we always think that there's a lot to learn, but today there's a package for almost and a module for almost everything. You just need to know where to look. So I've given a link here called pypy.org. You can always look it up. There are various modules. So let's look at one here. I have gone and picked up a module called package called Style Cloud. And what it's doing is it's actually generating a word cloud. We all know what word cloud is, but let me just see if I can get that image. So all that I did is I had a JD, I had a job description here, and we often do this, right? We are looking at what words to use in our resume. So I had here and I thought, okay, fine, let me see what I can get out of it. And so it just gave me a word cloud with hardly 2 lines of code. Let me close. Hardly 2 lines of code, we were done. It's as simple as this. Okay, so most of it today is automated. There's not much that you can do. I'm not talking about data science, but there are a lot of other fun things that can be done with Python too. So it's the same with here. We're all looking at various code generators. That also can be done. There's practically a module for almost anything. So you probably can't see this on what I'm sharing, but it's popped up on my other screen. Let me just show you what happened. Bear with me a moment. So this code that I'm actually trying to do here, it has generated a QR image here, which I need to drag it from my other screen for some reason. If we have luck. Okay, I'm going to leave this because there's some issue with the file not coming up here. But when you run the code, run this code, it actually generates. So let's look at whether it's actually generated. I can navigate from here. Yep, okay. So that's what just happened with that file, okay? So it created a QR code here. So if you scan that, you'll probably get all the files to what I uploaded as well. But fun things like this can actually be done. So you can generate code. You can actually have given you some giveaway tips here on how you can cut, copy, paste. There's also here a YouTube downloader too. So given a YouTube link, you can actually download. So all these are examples of automation. So today's class was only to talk about how Python can be used and in different ways. So the last project that I would have spoken about is how you can read CSV files. So you can either read it with files, which we looked at. So we looked at a file reading way, right? Like we open a file and then we read it and we print that. There's also pandas, where pandas makes it easy by importing that pandas library. You read a CSV file. So the CSV file is actually artist, genre, instruments, labels, and concerts. And when you read it via pandas, it makes it very easy because it's like we have a concept called data frame. So you're able to get a table view of the data. Okay, so it makes it very readable and makes it very easy for you to also do analysis, data analysis. So there's a small, like this is a precursor to the other sessions with on pandas and NumPy, but this would help you to get a good idea as to how extensively it can be used, not only in web applications and data and automation, but also in data science. And that's finally where I get to use this, a lot of charts in my line of work, which you'd notice with CSV files, if it's like rows in thousands, it really doesn't speed up and do well. Pandas does better, but Pandas is also not the best when it runs into many thousands, but Pandas is definitely does performance-wise much better than reading using the CSV module that comes with Python. Okay. I think that's all I had to share with you. I will share the files. We've gone well over time. I know we kind of run out, but please do, you do have my contact details, so please feel free to reach out if you have any questions. I know some of the questions that came up here were also, I may have answered some. Let me see if I can.
Sorry for interrupting, ma'am. Hello.
Yes,
Yeah,
yes, please
guys,
go ahead.
as we proceed towards answering your question, I'd request you all to please fill in the feedback forms. Why? Because it helps us to conduct more such sessions in future. Yeah, we can continue now.
Okay, yeah. So just looking at few, I'll take some few basic ones. Any thanks for the feedback. Any popular use of Python in automation? Yes, kind of almost all. It depends what you refer to as automation. Like now for me, I refer my line of work, my previous workplaces, they were all automation. So sometimes even looking up, if you're sitting and looking at the Excel sheets manually, that's also automation if you're using Pandas. So I moved to using Pandas. Okay, so but if you're into engineering, your deployment scripts sometimes are used as Python. Your glue code sometimes is used as Python. Okay, so you might want to, like one of my examples was, we were doing some bit of data analysis using R, and there was MicroStrategy and all that. And then our application was a React application, and that data had to feed in. So there had to be some sort of code in between. The whole thing was rewritten in Python, and then it was stitched together using Python. So there are different ways in which you can use Python. Okay. Thanks, John. Thanks, Munawara. Thanks for your feedback. Implementing gradient. Okay, that's your next one. LinkedIn profile. Sorry, I hope I've taken all questions. Can we use fvalue in V3 or later, right? I think we looked at fstring. How do we create a list or dictionary with data from Excel database? Sorry, not covered in this section. I'll probably have to take some time to write the code and run it. So I'm aware that we've gone well over time, but yeah, I will put it up on the Jupyter file. So I will take that as a takeaway, and I will upload that code as well. Okay, so take that from me. I think I have answered most of it. Thanks, everyone.
So yeah, thanks a lot, Rose ma'am. On behalf of Analytics Vidya, I'd like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Yeah, thank you. Happy to be back again. Thank you so much for having me.
Guys, the recording of the session is being provided in our YouTube channel, the link of which you can be finding in the chat section too. And yeah, we also have another session lined up in at 3. So I request you, if you are interested, to please film that. And I guess this is it for the day. Till then, keep learning. Bye-bye, guys. Have a great day.